didn't drop it, we replaced it. Okay, I'm gonna skip number 2. And, come back to it.
Do that one.
No, I'm gonna come back to it.
Are we doing 3
I'm
then?
trying to judge which one is the most often that you see, so I'll come back to that one. Let's do 3. Now, I'm gonna do this one with you. That absolute value is throwing me a little bit, okay, because I don't know how to integrate with absolute value. So if that's the case, you should either do, you can do one of 2 things. One is you could try to make a sketch of it and do it geometrically, or the other thing would be to try to replace it with a piecewise function. I don't want to do
No.
piecewise. Let's make a little sketch of this. You guys know what the sketch of absolute value of x minus 3 is?
Something that's up. Is it the V? It's the
V-shape,
V
V-shape.
but down 3. Down 3.
No?
Is it like in 3?
Oh, to the left, left,
No,
left.
to the right 3. To the right 3. So it looks like that V shape that's to the right 3. So it looks just like the square root of x, I'm sorry, the absolute value of x, but it's been shifted. So here's a graph of y equals the absolute value of x minus 3. Now, we're supposed to integrate this from 2 to 4. Oh, this makes it much easier, doesn't it? Because this is geometric, so it looks like I could just find this and double it. Now, I don't know if my picture is really accurate, but could you tell me what this point would be here? 2, 1. So this has a height of 1, a base of 1. So the area of that triangle is 1/2 times 1 times 1, which is a half. But there's 2 of them. So it's going to be, the area is going to be 2 times that. 2 times a half. And so this is going to come out to be, so it's 2 times a half, which is 1. Is that the answer?
Yeah.
So now, do you see how I'm looking at this? These are all mixed up when you do the AP test. They don't say, you're in the substitution section, so go ahead and use substitution, right? They're going to just be mixed up and you have to think through, and that's part of the problem. I can't teach you how to identify which is which. You just have to go back in your mind and say, what do I have available to me? So you can do geometrically, you can just look at it and say the antiderivative, or you could use substitution. I think that's about everything we've had. If you're lucky enough, you can use a calculator. All right, let's go to this one. All right, now, when I look at this one, I'm saying to myself, I don't know the antiderivative, so should I try to draw a sketch of it?
No.
Okay, so now let's try u substitution. If I let u equal something that's inside, which I think I'll choose x squared plus 1. Now this will tell me if I should use it. If you do the derivative of this, is the derivative found somewhere in that integrand? Yeah, kind of. It's got an x at least. You're not allowed to add variables, but you can add constants. So I'm going to go ahead and add a 2 into there, but balance it with a 1/2 out front. So this is going to be equal to half times the integral of 2x, the square root of x squared plus 1 dx. Take everything one step at a time so you don't make mistakes. Now I'm going to go ahead and substitute. So I'm going to change the 2x dx to du, and the x squared plus 1 to u. Okay, now I can find the antiderivative. What's the antiderivative? I'm going to treat this like u to the 1/2 power. What's the antiderivative of u to the 1/2 power? Yeah, there we go. And this is plus c. It's an indefinite interval. Oh, but I don't want things in terms of u, I want it in terms of x. Oh, I can cancel those 2's also. So I'm going to go ahead and substitute back. And I only do that on indefinite integrals. And this is going to be 1/3 of that plus c. Now I hope that's in there somewhere. Yep, it is, isn't it good? Is that my answer?
Yeah.
Answer here. Okay. All right. Number 5. I like to ask these type of questions, and they're almost all of these substitution are on the multiple choice. So they're testing you to see if you really understand how to do this by putting a k in there. And look, it's an equation. It's equal to 12. So we're solving for k. Now, you're not gonna have a calculator for this. If you did, you could put it in there and solve it. But we're gonna go ahead and try this. Who's got an idea what I could do for this? Yeah, Danielle?
Could you set like the function equal to 12?
The function, like the integrand, this part right here? No,
Well, you
because
could
it's got the
factor,
integral.
could you factor
But
it
it's
out?
from
Yeah.
0 to 2.
0 to 2. See, what I understand, this is the area under this function from 0 to 2 is equal to 12, the area, not the function. Melissa?
You find the antiderivative and solve it for 2, and solve it and
Evaluate
minus
it,
0,
evaluate it
and then
from
that
0 to
equals
2.
12.
There you go.
Can you factor that out though into two
No,
separate?
don't bother, because what we're gonna do, the plan like Melissa said, is find the antiderivative, it has k in it, but that's okay. Evaluate it from 0 to 2, and then set it equal to 12 and solve for k. Okay, so let's try to find the antiderivative. What is the antiderivative of 2x to the third? It is? Oh, yes, it is. Okay.
What do you
Minus.
do with the next one? 'Cause it's like
Yeah.
k to the x
And
squared.
k is just a constant.
So you just leave
Just
it.
leave it as a constant, so it's gonna be,
1/3
yeah, kx
That's
cubed.
why I was wondering if you put 1 to
Okay, clear.
Oh, wait. Thank
2
you.
k.
Wait, is this right? Cube.
It's cute.
Cube. Okay, I got it. Okay, that's right. What's the next one? Yeah,
Don't
2kx.
you have to add a plus c though?
This is a definite, not an indefinite.
Oh, okay.
Yeah, we're gonna evaluate this from 0 to 2. Now, see, they got this nicely rigged. They said that this is equal to 12. They got a 0 in there, so that, thank goodness they do, because the 0 in all these x's is not gonna mean anything. So we're gonna just put the 2 in. So if I put in a 2, 2 to the 4th is 16. 16 divided by 2 is 8. Okay, now put a 2 in here. 2 to the 3rd is 8, and then it's gonna be 8k over 3. Plus, now put the 2 into here, 2 times 2 is 4, and we have a k there. And this is equal to 12. Okay, now this is just down to algebra. Oh, thank you. Is there more than one copy? There, looks, I don't know. Okay, thank you.
Do you need more than one?
You were good, thank you very much. Thanks. Okay, this is just an algebra question. How do you solve for k? I'm gonna choose to move the 8 to the other side. So I have this. Different ways to do this. That 3 is bugging me. Can I just multiply the whole thing by 3? Let's do that. I don't like looking at the fraction. Okay, so this is gonna be negative 8k plus 12k equals 12. I'll combine my k's, and I got 4k equals 12. Divide by 4, and it's just 3. Is that the answer? Is that right? Did anybody check the answer?
Yeah, that's right.
It is, okay, good. Okay, let's go to the next one, 6. Let's see, some of you may be able to look at this and say what the antiderivative is, and some of you can't, so I'm gonna assume you can't. So I'm gonna take and look at this, and I'm gonna let u equal, negative 2x. du is negative 2 dx. Is it all there?
Yeah.
It is all there, okay. So I'm gonna go ahead and put a negative 2 in here, but keep it balanced with a negative 1/2 up front. Okay, and this one's a definite interval.